Hello everybody, my name is Huat. For today's video, we are going to be discussing about a very interesting math concept, which is called matrix algebra. So, what is it actually? Matrix algebra is basically just like linear matrix and linear algebra. And so matrix is basically the study of matrices, the studies of numbers, of data, and of different math elementals. So what is it actually? It usually is shown in a rectangular array. So the rectangular array is usually shown like something like this. So like if we are given matrix M, we will represent it like this. Matrix M equals to, and then we have these rectangular arrays. I'm going to write them as RA. Alright, and so inside these rectangular arrays are numbers and the mathematics objects such as like numbers, different arithmetic problems, and yeah, that's it. And it's usually shown in rows and columns. And each numbers is called as an element. So let me show you. Here, let us have matrix M. We have let's say 10, 15, let's say 10 and 16. Alright, so here is our matrix M. And this is a basic matrix that everybody should know. So first, it's about its rows. So its rows here. It has two rows. First row and second row. It has two columns. First column and second column. Actually really easy, right? And each number here, we call these elements. Alright? So that's actually really basic. And as the example below I've shown, as the example below that I have already shown you guys, here, our matrix here is basically named M. And you can notice that it's actually a capital letter. So a matrix is usually denoted by capital letter. It could be A, be B, be M, be P, any letters in the alphabet. Alright? And when we are reading, we call it MXN matrix. So what does M and N here stands? Well, M and N here stands for the rows and columns. Row comes first, which means rows is M, and column comes second, which means columns mean N. So let's look at this matrix. We have two rows and two columns. So we would call this matrix is 2 times 2 matrix. Really easy, right? So now I'd like to come to its basic principles and what actually could be done by these matrix algebra. So first is about addition and multiplications. So those are the basic arithmetic problems that we could face in matrix algebra. So first we have is addition. So addition is something very, very important. So if we have like an element that has the same, it like have the same corresponding elements, then it could be added. Let's say we have number A, and A equals AIG. We have B here, and B equals BIG. So if they were like in the same corresponding elementals, like we have here, it's like maybe 10 and 15, then those could be added. And so like that, we could add A and B together. That's actually really simple. Next we have is multiplication. Multiplication is basically just like addition, but it's a little bit more complex. So multiplications here is like when you're adding two matrices, right? Then it is defined when the number of column here is the same as the numbers of rows for the other matrix. So what do I mean here? Let's say here is our first matrix. Alright, it has 2 rows and 2 columns. Let me write out another matrix. We have matrix n equals to, alright, so this matrix, let me put out numbers. Alright, so this is our matrix. Pretty easy, and we have this is 2 times 3 matrix. No, like 3 times 2 matrix. I'm sorry for that. So when we look at this matrix, we know that they could be multiplied together. Why? Why so? Because the first matrix, it have 2 columns. Now the second matrix, it has 2 rows. And so basically like that, then we could understand that matrix M and N could be added together. And it could be multiplied together. I'm sorry for that. So yeah, that is the second principle of matrix algebra. Next, we also have identify matrix. This is actually a really important thing in matrix algebras. So it's like you identify a square matrix of what it is. We also have a transpose of matrix, and it's like formed by snapping its rows and columns out. So now I'd like to come to its applications. First, let's look at its application in math. So in mathematics, it has like unlimited uses. So first, it could be used for linear equation. So as I've just said in the beginning of the video, matrix algebra is basically understood as linear algebra. It's just like nice way to show out data and etc. So when we have to solve a linear equation maybe, then we could use these matrix methods such as like the Gaussian eliminations or inverse style matrices, and it will help a lot. Next we have is transformation. So transformation is also important. It represents and perform linear transformation in geometry, etc. Alright, next we have in daily life. So in daily life, it also has a lot of uses. First is on computer graphics. So matrices are used to perform transformations such as like rotations, scaling, and transitions, and computer graphics. Next, on data representation, it could be used to store and manipulating data out. So it could be a really clear way to represent data. Lastly, but also the most important thing, is in business. It could be used to model and solve problems irrelevant to financial modeling. So financial modeling is actually really important, and by applying matrix algebra into solving, it could be way much more easier. Lastly, it's about operation research. So it could be really helpful. It could optimize logistics, supply chain management, and resource allocation through matrix algebra. Alright, so after this video, I've explained clearly out on what is matrix algebra actually. What does it mean? What are its key concepts? And how can we apply it in both mathematics, business, and daily life? Thank you for watching. Goodbye.